right. Okay. So the first thing I'd like to do is just mention that, it takes a team of people to do this sort of, well, any building, but of course this building, there was a lot of, it's science heavy, and there was a lot of help. At the time I was working with Terry Marklevitz. When I started the project, I finished it on my own, but it takes leadership certainly in the client's perspective. Peter Crockett was the CAO at the time, and he had a mandate to convert all of Oxford County's buildings to net zero by 2050. And this was really one of their first experiments, at least with the new build on other than a residential project. And so, aside from the general contractor, there was, engineers that I've worked with for many years. And Steve Cooper was the structural engineer. Greg Leskin was the energy consultant and the solar designer. Chris Hadlock was the energy modeler. And, there was a slurry of other people helping to realize the information that was required to build the building. So as you know, probably by now, that the Oxford County Waste Management and Education Center is at a landfill. There was a century-old house. I don't know if my cursor is visible. Is my cursor visible?
Yes.
Okay, well, that was a house, the farmhouse that, for the 100 acres of what is now a landfill. And it was certainly inadequate for staffing and administration. And they wanted to allow the building to be an interpretive center to help people understand how waste is dealt with. This is the final product from the air. You can see the solar array, which offset net zero the entire site. The building itself was just this one little array here, which is 24 kilowatt. So there was, operations, the scale is here, so visibility to it was important. This is a service building, and there's another couple of other outbuildings on the property, but they're all net, the site is now net zero. So, I mean, to put into words a few of the ideas and feelings that were important at the beginning, I won't go through everything because there's a lot of material, but anyway, as a program, you're generally starting with needs for the building. And in this case, there's two sort of sides of things. One is, the staff, the fellows that work the fields and, operate all the equipment. And then, of course, the administrative side and the general public visiting the site. And then there was the idea of the school buses of children being able to come and then learn about waste management, and then also as a regional area to have meetings in the evenings, because it was although it's not in the middle of Woodstock, it's certainly in the middle of in the neighborhood. So that was the program. Some offices, a staff room, meeting room, interpretive center, some storage, showers and washrooms for the staff working. Sometimes it'd be nice for them to shower before they go home. Here's just a quick sketch of an idea of the geometry of the building that would allow, in this case, it's just a daylight study. There's the building perimeter per area was very important. I mean, all of the constraints on this building to absolutely minimize the demands electrically, because it's of course being serviced only by solar. So you can see the geometries, the gray areas where it won't be direct daylight. I mean, the whole thing can be lit by daylight, but it was just an exercise in geometry. The next one is when we have the modeler involved, we learn what is the types of fenestration that we're permitted to deal with on each of the various elevations. And then there was the debate, is this going to be a ground solar mounted service building, or is it going to be on the roof? Certainly my preference was ground mount. And when you saw how much there was to offset the site, it became fairly obvious that we didn't have to clutter up the roof. Now what's happened? How come I can't? Okay, so anyway, just to begin with a couple of sketches, if you gather enough information about what you're trying to do and contextual items, and then, with any luck, you get an idea or two. And in this case, there was the idea of a sloped roof. We still hadn't abandoned the idea of solar on the roof at this point. I wasn't aware of what we'd end up doing. But these were early sketches. At this point, the roof is symmetrical, and there's the idea of a clerestory around, and the idea of the walls emerging from the ground. There's another sketch. In this case, we can manipulate the terrain any way we wanted, but there was a little bit of slope, not quite as much as I've indicated in the sketch. And then there's the thought of, what do we do with rainwater? Is it something that would be collected? Is it something that we would feature? It ended up being a feature because collection in our part of the world isn't yet practical. There's no ROI in it. And then the quest of material selection. Certainly, rammed earth came to my mind pretty quickly when you consider the purpose of a landfill and the layers of debris that are buried in debris and buried in debris and buried. So I thought it was a very interesting material to look at. It's certainly not something that's common in Ontario at the moment, but it was just something that immediately spoke to me as a potentially exciting material. And then for the roof, this is the canopy at our local Salvation Army, but there was a structural wood deck, which becomes both the structure, but it's also the finished ceiling. So I thought that might be a practical application for a wood deck, and they're beautiful too. So, and then the other material to look at, forget the canopy in this case, but this is the Hellenic Center edition did in London. And the insulated panels, they're SIPs, they're called. So they're very, very economical, where you get a pretty intense R value with this panel. It's solidly filled with rigid insulation. And then, okay, so at the beginning there was thoughts of minimizing the envelope, introducing natural light, of course. So you don't need to turn on your lights. And the thoughts: should we build out of lumber? Should we build out of steel? Is rammed earth even possible versus concrete or masonry? The stormwater quality, which is something we can quite easily deal with. Rainwater I just mentioned, and then the idea of the solar PV, was it on the ground or on the roof? Here's some early sketches of the idea is sort of developed into at least a floor plan at this point. The roof has it's still symmetrical at this point, and then there's this idea of the fenestration to see, are we on the money, or on the mark at least, with the amount of glazing proposed. Here's some early 3D sketches of the thoughts of retaining walls, and then just the general geometry of the building. You can see the clerestories underneath the roof. The roof design is intended to shade the clerestory from heat gain, because heat gain, of course, is one of the constraints, because you don't want to be trying to cool your building overly. So just discussing with the owner, what do you think what materials should be looked at? Here's the idea of SIPs. You can see the connections and the insulation within the system. Again, very, very inexpensive materials to use. And I had some experience at the Hellenic Center, so I thought it was worth consideration. But when you examine the detailing within the SIPs construction, you see that there are numerous places for leakage and numerous places for thermal bridges. So that was dismissed very early on. Then I went on a quest to learn, is it possible to do rammed earth in Ontario? And thanks to James Blackman, I'll talk a little bit about him later, but this is a picture of his house in Muskoka. So, I was zipped up to see him and meet him, and then learn a little bit about it. So on this one, his wall construction is a little bit different than what we needed, but you can see there's an interior wythe here, and then a cavity of insulation, and then a veneer on the outside. So this one holds up the roof. There's our insulation barrier, and continuous insulation, sort of underfloor, up the walls, and over the roof, without any thermal breaks, is sort of the goal to achieve. So here's a material that I found, possibly being done in Ontario, and also it's a public tender. So I had to find 2 others that would be contenders to allow competitive bidding. And then of course, water quality is something that we, more so the idea of featuring, the idea of noticing about water as an education tool really in the building, because of the, and then of course some mitigation for the quality, but it was, again, it's very easy to do. So here's just the review. Do we do ground mount or do you do roof mount? Of course, with roof mount, you've got to realize you've got to replace the roof every so often. So it's one of those things you have to sort of life cycle cost and look at to see what's the most practical. And here's a diagram of what is now deemed as a passive house. Sure, it was invented or thought of as an idea in the 60s and 70s, where people were building little solar ovens that would overheat inside the hills. But the Germans have invented a standard that's it's pretty ambitious for our climate. There's another, FIAS is what the Americans have come up with as a comparable system. But you can see how intensely insulated the building is, and as important as the insulation is, the detailing to seal the building are paramount. Here's another look of a wall assembly, but notice underneath the slab. So here you've got a concrete slab, you've got a footing, and you see this is the exterior insulation. It continues, and then underneath the slab you have this enormous continuous band of insulation, and the variables are how much to do, and this is all something where the scientists help. Here's a sketch that's at least at the beginning of the idea. I thought that here's a rammed earth wall, with the bearing width veneer, and then the insulation middle, and you can see there's a compressive type of very very dense insulation that the system sits on, but you've got a continuous insulation all the way around the building. Here it is underneath the slab, widening for the bearing, and then again continuous insulation up, and then the windows of course are high performance. I can talk a little bit about those if there's time. And then here was this idea, that original idea I had about the roof deck. So this would be bearing on beams, of course, and underneath spanning a certain distance. So here's a solid bunch of 2x4s as your ceiling, and then another layer of insulation on the roof, of course. What happens though is this became in the model problematic, because this was just too much thermal bridge, even though that our wood has a value of well, more than 1 per inch. So it's not inconsequential, but it was still, as it modeled, far too big a thermal bridge for the system to work. And the glazing here, we have triple, whether, and in this case, they were made out of wood. Unfortunately, in this case, they were made locally. So then again, just analysis of what can we make out of, what building materials could be used to be featured in the building itself to speak to the idea of waste management. So here's an obvious idea, at least glass. It can be placed in concrete floors, which can be quite pretty. Here's reclaimed lumber. In this case, it's pallets, just to feature wall. And then I'm going to jump to the building form and just the philosophical idea of this building. It began with the idea of layered walls or layered material sort of emerging from the earth. And then I don't know how many of you have, now when we go to the landfills, you deposit your materials in a bin, but I certainly remember many times in the renovations over my life, driving right into the landfill. And of course, when you're unloading your truck, you're going to be stepping on lots of objects, glass, for instance, which crunches under your feet. So I thought that the idea of the roof being an idea of a broken object sitting on these walls emerging was an idea. And the idea of having these rammed earth walls emerge from the earth would have been beautiful, but of course there's budgets and constraints in every project. So this was the idea that I was very excited about. And of course, this is a drawing used as a takeoff to then, during the process of being responsible and trying to understand how much your building's going to cost, especially when you're doing some things that haven't been done. I often reach out to sub-trades to help get a better idea of what the costs are really going to be when the thing goes to tender. And certainly rammed earth was something I was able to understand and control, and my retaining walls just were not possible in the budget. But you go through a bunch of research to determine how far you can go. This is an early site plan. You can see the building is here. The idea of the public, the public had to enter before the weigh scale, because it's kind of obvious if you wanted to visit. And then the staffing and landfill operations were further to the south. So the idea of staff coming in one way and public coming in another was, of course, you want to limit the number of entrances, but two is a must-have. And then when we were getting down further along the design, this was a sketch that I had done did, and this was to give the rammed earth trade some idea of what we were trying to do. We did a mock-up with some with a little bit garish colors, which frightened the owner a little bit. And the other thing that's quite interesting is when you build this, you have no idea what you're getting until you peel off the formwork, which I'll be able to show you a little bit later. So there's an important drawing, at least from my perspective, and there's a little bit of my blood on the edges, and gray is a wonderful foil for red. So there's the site plan, as built. And here's the floor plan. So the public comes in here. This is the interpretive center. There's circulation through the building. But this is the lunchroom. 7 is a storage room. This is a meeting room. Accessible washrooms, electrical room. The bullpen. This could staff more people than it does at the moment. An office, and then the principal office here. And then here you have where generally men come in with their dirty boots and scrape them off out here. And then this is their locker room, laundry area, and then obviously washrooms to get cleaned up. There's lockers here for the office staff. So, the bulk of the gentlemen working in the fields really don't have to sort of penetrate into this part of the building. So we have administration, we have public use, and then we have the staff use. So it's fairly compact. It's not a large building, and it's only 4,000 feet, including the walls. Here's a couple of cross sections. The idea was to feature water. I'll get into that a little bit more, and then you can see the north elevation lighting in the drawing. But again, sections, and then the very, very simple and primitive footings for the thing. And if we could see closer, you'd see there's insulation continuous underneath footings, even, or at least there was in the design. The contractor thought he could skip them. And then we were somehow, never mind. Anyway, so here's a construction shot. And I just wanted to talk a little bit about water, because water isn't something you can scale. I learned this from Dan Huser many, many years ago when we were trying to design a water feature for a developer. And he mentioned that, Michael, you just can't scale water. You got to do full-size models or mock-ups that are actually full scale. And I didn't have that luxury. And so I've got this roof, which is much closer to, it's a little bit over 5,000 feet if the building's 4, because you have these overhangs, and then they're exaggerated at the 2 points of entry to give you overhang where you're entering the building, so you can stay dry as you come in the building. And then, of course, as I mentioned, shading the clear stories was critical. So here we've got one valley. These were little diverters that I put in just because I was a little bit nervous about the water rushing off. And then this was a ditch pipe, cut and put on its side. And then this is the single scupper. So, where to locate this thing became a bit of a, interest and concern for Michael. But I was a reasonable guesser, because we have a photo cam. If I have time, I will show you some very, very short time-lapse videos of the construction, which are quite fun. But Mike Amy knew how concerned I was about this, and he helped he identified this photograph, and this was a deluge. This was about as much water that's going to come off the roof, at least in our climate. And I managed to nail it close enough, so I was happy about that. Now getting to the building finished, the landscape design is quite simple. You just got one color here, and then this water element is over there. So there's the front door, our north elevation. So now we're looking at east, and this is a morning I met a photographer on the building. I took a couple of my own shots while he did the nicer ones. This is the north elevation, and here you can see the layers of the rammed earth, which is it's, in this case, it was vernacular gravel, sand, a little bit of Portland, and it's laid very loosely and then compact with pneumatic hammers. It's almost like a wet sand. It's not really moist, and each time you stop at the end of the day, you have a cold joint, but it somehow manages to work out. Here's the only construction photo I have. Again, I could talk for hours about this building, but I thought I'd give you one which gives a reasonable close-up, and you can see the idea of the roof geometry allowing a generous overhang as you enter the building. This is the staff entrance, and it's a very simple construction, really. You've got rammed earth walls, which is essentially a low MPa concrete, and then TGIs and LVLs and so on holding up the roof. So here's the same elevation in its final form with just steel fascia. The wood windows were, again, I mentioned, made locally, and so you have your staff entrance. And then you can see the glazing with the idea of this object sort of floating in places. That's the locker room, the administration office here, and then you've got your meeting room in there. So again, now we swivel around towards the front of the building again, with the PV array in the background, and then the idea of the landscape. So here's the front of the building that you would see as you come in the parking lot. And so now to go inside the building, polished concrete was sort of an obvious choice. It's resilient, it's inexpensive, sometimes looks nice. So here's the locker room. There are lights on in the photograph, but you do not need to turn the lights on in this building much of the time. So, not a big space, but large enough for the crew. The lunchroom, not a huge room, but again, there wouldn't be more than the 12 people that were required to be eating at lunch at a single time. They would shift as well, so sometimes it wouldn't even be that crowded. This is the director's office, who can now see the scales, and so you can kind of keep an eye on what's going on. This is the bullpen. Ironically, I managed to slip away to Turkey for a whopping 2 weeks, and the administrator, for some reason, did not like my exposed LVL and put barn board on the beam, which, to my chagrin, when I returned, had to remain. Wasn't part of the vocabulary, however. Things happen. So this is the meeting room that is directly off the interpretive center, and you can see how the feeling of the rammed earth is, it's inside and outside, even though it's kind of two parallel layers on top of each, on either side of the insulation. And here is the interpretive area, where there's a number of displays to indicate the various processes that happen, and also will teach people how they can do a better job of looking after and trying to minimize their waste. Here's a wall that was constructed out of, we tried pallets, but the animals made them sort of not too reusable, at least in a practical manner. So this was, we went to a barn that was, within 2 kilometers of the building, and the farmer offered up a couple of the beams that had fallen down, and then I just directed the sort of ad hoc flavor of this. So this is a great wall for diffusing sound. I've done this sort of thing in musical spaces before, and the patina of the older the outside of the beam and so on gives kind of a language that's, again, has some sort of idea of layering and time. There was a wonderful few displays placed with the idea of, again, demonstrating, what we're doing to the world with our plastics. I thought this was a pretty powerful idea. Again, the detail of the what's called the feature wall, at least. And here's an interesting piece that putting some of the debris, in this case glass, within the floor. And I had a little bit more ambition with this part, although I was very disappointed with the performance of the contractor. But I donated some of my prized fossils from a collection that weren't getting a lot of visibility, and placed them during the pour. I mean, this is just, one spot of it, but you can see one or two. Unfortunately, when I asked to grind the concrete, they did their thing and ran away, and I was begging them to come and grind this area because there's some beautiful fossils right very near the surface underneath my feet. So that's just a bit of fun. And there's Michael, happily standing in front of his building. And then there's a couple of slides I'll just I added to the presentation just late last night, thinking about they might be of interest. Just some specifications where the R values and so on, and just this idea of the 24 kilowatts, which is not a lot of electricity. And then for this, I got a little bit of notice. Got one page in Canadian Architect, but if anybody's interested and wanted to read the sort of nitty gritty, Toronto Focus magazine, this issue, it's out for a number of months still. So if you went to Toronto Focus magazine, there's something there to look at, which was really nice. And then finally, after pursuing the client to say, the intention of this building was to become a net zero certified by the Net Zero Buildings Institute. And although we did the building almost, approaching 3 years ago, Hydro took almost a year before we could throw the switch. And after that, it required another year of measurement by and scrutiny by the Net Zero Building Institute to, get their certification. And we did. And apparently we were the first office building. Office building is a bit of a stretch, but it was categorized as an office building. We were the very first one in Canada. And then the third building period in Canada to be verified, and then the second building in Ontario. And the thing that we don't have time to go to the details of the site, but the point was we were net positive. The first two buildings had sort of a -1, margin, and ours was at -13. So we're definitely generating more energy than the building's using. I don't know if that was conservative estimating or just everything coming together well. So that's something to be proud of. And now how do I close the screen so I can show you a quick video, assuming we have time. Which button do I push? There we go.
Yeah.
So I'm just going to put that away. And then, do we have 2 minutes, or should I just...
Show the video.
Okay, well, there's two. We'll do the bigger one. Oh, there's full time. Okay. So this was from a top of a, I think if I just click that button, we're all set. So this was from a communications tower, and it was taking a photograph every 10 minutes. There's that primitive foundation I spoke of. Then there's the foundation, which was done improperly, and then now we have the formwork for the rammed earth that's gone up. And they're furiously putting it together. Now the formwork stripped, and this is now you get to see what you actually have to live with, or like it or not. And now they're putting the now they're putting the ductwork in the ground without the insulation. So that wouldn't do. And after some trials and tribulations, we insisted it must come out. I guess you couldn't see it on the ground there, but it all came out again. And now we have a local contractor, Contract Framing. So we had James Blackman doing the rammed earth. After this building, he went to Africa, believe it or not, to do 18 buildings, and I haven't seen him since. But then we had contract framing, which was another good trade. So we had two very, very good trades. And then I used a Mennonite group and specified their product for the windows, so we had these three elements that came together, you know, and a lot of scrutiny. I was at the site quite a bit. There's the water feature going in, a bit of landscape. The owner was kind enough to let me do the landscape design, so it's fairly simple in color scheme and so on. And then when this thing matures, it'll be nice. So there's a short video of about a year's work of over the period of construction. And I guess now would be a great time to entertain any questions.